Hello everyone, this is Andreas from Flightronix. Today I want to show you my servo controller using the CoolRunner CPLD cape and the BeagleBone. You can find information about the demo here on my homepage, flightronix.se. When you get here, just click on the BeagleBone capes and select the CoolRunner-II CPLD cape. Here you can find some basic information about the CPLD cape and the key features and the links to the design files, documentation and the hardware examples. We'll click on the link and go to the hardware example page, and it will transfer us to the Google code page where I will submit all my source files for the CPLD cape. To download the source, you can go to the source link here, press it, and then we will use the SVN checkout command. Just copy this, and then we will open a terminal window and just step into an empty folder. Do this and paste the SVN checkout command. We'll also add, just to check out, the I2C Servo controller. Okay, so now it's checked out. Then we have to start a development tool, the Silings ISE tool. So I have a little script. Let's do that. Just execute it by pressing this, and it will start a development tool. So, all started, we'll have to open our project. You can do this here by clicking on the Open Project, go to the CPLD cape folder, and go to Projects, to Controller, and the project file. Press Open. Okay, I think you have used this program before, but if you have not, up here you have the files, the project structure. It's the I2C transceiver, a servo pulse generator, and the UCF files. The UCF file is a file that defines which outputs and inputs that the different pulses will use on the CPLD. Down here you have the user constraints file. If you want to edit it now, you can just click this, edit the text. You can just look into it. And here you can see that the clock input, it has a time specification for the timing, and down here we have the localizations of the pin assignments. Here you can see that we have two servo pulse outputs. We have a reset input and the I2C input and output ports. So let's build this. Okay, you can see here it's implement design, but just to make sure that everything is reset from the beginning, just go in the project menu, clean up project files, press OK. So now we are in the right state to begin to build it. Right click, implement design, rerun all, and then it will start the build process. Synthesize, translate, and the last step will be to generate the programming file. Okay, it's done. Great. So, that's done. Click this, and now we have to upload the file into the CPLD cape. I'm using the impacts from Silings. Same here. Start it. It's impacts. Okay, it says it will to change the directory, and it will automatically detect the CPLD that's on the cape. So what you can do here, click it, right click, and the first thing you want to is to select, assign a new configuration file. So it's here, and we go to the folder for the I2C Servo controller and just select the top file here. Then right click again, can use the program and press OK. Now it uploads and the program succeeded. Perfect. So now let's log into the system, the BeagleBone. I have a fresh Ubuntu installation on it. So let's do the SSH, the IP address, and the root user is Ubuntu, and let's type in the password. Okay, so we're in. Just to simplify this, I will do it like this. Not safe, but okay, let's do it. Okay, so one thing that we have to know is where the I2C bus is located. It has number 3 in this Ubuntu installation. So let's start to detect it and see what address the I2C controller has. So let's go up here and see if we can find it. Here it is. I2C detect on number 3 bus. Press yes. And here you can see that it has been detected on the number 20 hexadecimal address. The use says that it's just a taken address that's used by the system. So now let's see if we can fire up my webcam. Okay, it's not a very good webcam, but also you can see here is the BeagleBone and here's the 2 servos. So the servo controller ranges from the data value from 0 to 90 hexadecimal. So 45 should be the center of the servo, and 0 to the left and 90 to the right. So, okay, so here is the I2C set command that we should use to set the servo positions. Servo number 0 is a 0 address here, and the other servo is on address 1. So let's see what happens if we set this to the center position. If it's not already in the center position. Yep, you can see the servo moving. Just try to set the other one also to 45. Yep, it also moved. So now we can use this command to set the servo positions. Let's play a little bit, like 0 and like 90. And you can do the same with the other servo. Of course you can do any other type of program that you can access the device for the I2C bus. Here. So you can do open and send command from a C++ program or other source just to control the servos. It's also very easy to expand the hardware to make it access a lot more servos, but as you can see, this is just a short test of the card and see what you can do. Okay, that was all for me now, and thanks for listening.